Hello everyone. In this video we are going to see about industrial health hazards. I am Dr. T.M. Inbamalar, working as professor in the Department of Electronics and Communication Engineering, RMK College of Engineering and Technology. First, let us see what are industrial health hazards. Actually, those are diseases caused by the exposure to specific hazards at the workplace. Hence, these are also called as occupational diseases. Depending upon the occupation, an industrial worker may be exposed to many types of hazards. So, let me tell you about the important 5 types. Physical hazards, chemical hazards, biological hazards, mechanical hazards, and psychosocial hazards. Let us see in detail. First, let us consider physical hazards. So, this physical hazards may happen because of heat and cold, light, noise, vibration, ultraviolet radiation, and ionizing radiation. Now, if we see in detail about heat and cold, first let me consider heat. So, this heat is having a direct effect as well as indirect effect. If we see the direct effect of heat, it produces burns, heat exhaustion, heat stroke and heat cramps. If we consider the indirect effects, we all know if we are in a sunny area or if the place where we work is too much hot, we cannot concentrate well and we cannot perform the best. So because of that our efficiency decreases. So the one of the important indirect effect of extreme heat is decreased efficiency. Also it leads to increased fatigue and enhanced accident rates. Now let us consider the impact of cold. We all know extreme cold is also not comfortable for the worker in an industry. So there will be some effects, and the effects associated with cold are chilblains, erythrocyanosis, frostbite and general hypothermia. Now let us consider the impact of light. So both poor illumination and excessive brightness have its own effects. So first let us consider poor illumination. So the effect of poor illumination can be studied under acute effects and chronic effects. So acute effects can be actually immediate effects. For example, the acute effects occurring due to poor illumination are eye strain, headache, eye pain, lacrimation, congestion around the cornea and eye fatigue. The chronic effect means actually it is appearing because of the impact of poor illumination for a prolonged period of time, and the chronic effect is minus nystagmus. Now let us see the impact of excessive brightness on a worker. The effects due to glare are discomfort, annoyance and visual fatigue. This also leads to blurring of vision. Now let us move to the impact of noise. Actually, this industrial noise leads to both auditory effects and non-auditory effects. First, let us consider the auditory effects. Basically, auditory effect means it is a hearing loss. The hearing loss may be a temporary hearing loss or a permanent hearing loss. And if we consider the non-auditory effects, it can be nervousness, fatigue, interference in communication, decreased efficiency and annoyance. So, if we consider the degree of injury from the exposure to the noise, it depends upon a number of factors such as intensity and frequency range, duration of exposure, and individual susceptibility. So if we consider the intensity and frequency range, intensity, that is loudness, which is measured in decibels, is having a serious impact. Moreover, how much period the worker is exposed to noise, that also matters. And the individual susceptibility, the susceptibility of the workers also varies from one individual to other, and the aging creates more impact. Now let us come to vibration. This is encountered in work with drills and hammers. When the worker works continuously with such machines, it affects the hands and arms. So the blood vessels of fingers may become increasingly sensitive to spasm. It may also produce injuries of the joints of the hands, elbow and shoulders. Now let us consider atmospheric contaminants. The forms of atmospheric contaminants or substances appear in the air in many physical forms, which are generally defined by the industrial health engineer as dust, fumes, gases, mist, smoke and vapors. Let us see in detail about one by one. First, if we consider the dust, they are solid particles generated by handling, crushing, grinding, rapid impact, detonation and decryptating of organic or inorganic materials such as rock, ore, metal, coal, wood grain and so on. Dust do not tend to flocculate except under electrostatic forces. They do not diffuse in air but settle under the influence of gravity. Next, let us consider fumes, which are solid particles generated by condensation from the gaseous state, generally after volatilization from molten metals and so on, and often accompanied by a chemical reaction such as oxidation. Fumes flocculate and sometimes coalesce. Gases, normally formless fluids which occupy the space of an enclosure and which can be changed to the liquid or solid state only by the combined effect of increased pressure and decreased temperatures. Normally gases diffuse. If we consider mist, they are suspended liquid droplets generated by condensation from the gaseous to the liquid state or by breaking up a liquid into a dispersed state, such as by splashing, foaming and atomizing. Next, coming to smoke. Carbon or soot particles less than 0.1 micron in size resulting from the incomplete combustion of carbonaceous materials such as coal, oil, tar and tobacco. Vapors, the gaseous form of substances that are normally in the solid or liquid state and can be changed to these states either by increasing the pressure or decreasing the temperature alone. Vapors diffuse. Next, let us come to chemical mixtures. Frequently in industries, one compound is mixed with others to produce a more desirable product, that is, decrease its flammability or toxicity or increase its solvent power. If one compound is less volatile than the balance of the mixture, the more volatile chemical will evaporate more rapidly and thus change the composition of the mixture and eventually alter its properties as well. For example, trichloroethylene is often mixed with other solvents to decrease the health hazard of trichloroethylene or to decrease the fire hazard of more flammable solvents. If the flammable solvent is more volatile than trichloroethylene, its vapors may be flammable even if the liquid mixture is not. When it has evaporated, the liquid remaining may be mostly trichloroethylene and its vapors will have the toxicity of trichloroethylene. Now, how to detect and sample? Although the presence of a number of industrial atmospheric contaminants may be indicated by the senses of smell and vision, these senses are by no means so refined that they will detect harmful concentrations or distinguish a toxic substance which may be masked by the presence of an innocuous compound. The qualitative and quantitative measurement of a worker atmosphere's contaminants generally is the job of an industrial hygiene engineer. Frequently, it is necessary to take air samples at a particular place and time. Samples must be taken with a purpose. For example, it must be decided whether the sample is to be representative of the workroom air, the site of the worker, or the source of the contaminant. It must also be decided what time the samples should be taken in order to obtain the conditions of representative of the problem. Thank you.